Imagine a high-end, chemical-grade fertilizer being poured onto a dying plant, only for it to wither while a few feet away. A discarded banana peel and a handful of rice water are causing a literal explosion of green growth. We've been taught that healthy plants require expensive, synthetic blue granules and precise laboratory formulas, but the reality is far more chaotic, cheaper, and infinitely more powerful. Most gardeners are unknowingly throwing away the exact fuel their soil is starving for, opting instead for store-bought junk food that provides a temporary spike but eventually leaves the ground sterile. What if the secret to a threefold increase in growth speed wasn't a product you buy, but a biological process you've been accidentally stopping every time you take out the trash? It starts with a simple observation of the forest floor. No one is out there with a spreader or a bag of NPK-balanced pellets, yet the biomass is staggering. This led a small circle of researchers and regenerative farmers to look at trash not as waste, but as a dense battery of locked potential. But here, where it gets interesting. You can't just throw kitchen scraps on a plant and expect a miracle. In fact, doing that can often attract pests or cause root rot. The bridge between waste and superliquid is a process called anaerobic fermentation. It's a method that doesn't just decompose organic matter, but actually predigests it, making the nutrients instantly bioavailable to the plant's root system. Think of it as turning a raw steak into a protein shake for your soil. One of the most famous proponents of this was a man who noticed that traditional composting took months, and even then, much of the nitrogen escaped into the atmosphere as gas. He wanted a way to keep that energy in the liquid. He discovered that by submerging specific kitchen waste in a controlled, low-oxygen environment, he could create a microbial tea, so potent it could revive a yellowing seedling in under 48 hours. That sounds like a bold claim, doesn't it? The science, however, is remarkably grounded. Most commercial fertilizers focus on three elements: nitrogen, phosphorus, and potassium. While these are essential, they are the equivalent of a human living entirely on sugar and caffeine. The fermented liquid made from kitchen waste, specifically fruit peels, vegetable scraps, and even eggshells, contains something the blue granules never will: live microbial life. When this liquid hits the soil, it's not just feeding the plant, it's recruiting an army. The microbes in the ferment begin to break down the minerals already present in your dirt, minerals that were previously locked and inaccessible to the roots. And this changes everything. Suddenly, the plant isn't struggling to find food. It's being fed by a symbiotic network that expands its root surface area by hundreds of %. This is why we see growth rates that seem impossible. It's not magic. It's the efficiency of a system that has had millions of years to perfect itself, now concentrated into a single watering can. So, why isn't this the industry standard? Why are we still hauling heavy bags of chemicals from the hardware store? The answer is largely structural. You can't easily patent fermented kitchen waste. There is no massive profit margin in teaching a homeowner how to use a 5-gallon bucket and some old apple cores. Our modern agricultural system is built on the input-output model. You buy the seed, you buy the fertilizer, you buy the pesticide. If the soil becomes self-sustaining, the business model collapses. But for the individual, the logic is undeniable. To create this liquid gold, as many call it, you don't need a lab. You need a sealable container and a specific ratio of green waste, think leafy greens and fruit scraps for nitrogen, and brown waste or simple sugars like molasses to feed the initial bacterial bloom. By adding a source of beneficial bacteria, like the water used to rinse rice or a splash of unpasteurized milk, you kickstart a microscopic feeding frenzy. Within 2 weeks, the liquid transforms. It loses the smell of decay and takes on a sweet, vinegary aroma. That's not the full story, though. The most common mistake is using the liquid straight. Because this ferment is so biologically active and nutrient-dense, it is actually hot. If you pour it directly onto a plant, the acidity and concentrated salts can overwhelm the delicate root hairs. The secret is the dilution, usually a 1:10 or even 1:100 ratio. When you see the results, the first thing you notice isn't just the height. It's the color. The leaves take on a deep, waxy emerald hue that is nearly impossible to achieve with synthetics. This is the result of micronutrients like magnesium and iron being delivered in their chelated, organic form. But then, something even more surprising happens. Plants grown with this fermented liquid develop a natural resistance to pests. Because the plant is so healthy and its cellular walls are so thick, insects like aphids and mites find it much harder to pierce the leaves. It's an internal armor built from the bottom up. We've been focused on killing the bugs, when we should have been focusing on the health of the host. It's a complete shift in perspective. Instead of viewing the garden as a series of problems to be solved with chemicals, we begin to see it as a digestive system that needs to be fed. We are currently standing at a crossroads in how we interact with the earth. One path leads to more expensive, more synthetic, and more sterile environments. The other path, the one hidden in your kitchen bin, leads back to a cycle of abundance that costs nothing but a little bit of time and a change in mindset. The explosive growth people report isn't an anomaly. It's the baseline of what nature is capable of when we stop getting in its way. We have been throwing away the most valuable resource on the planet, thinking it was trash, while the solution to a more vibrant, self-sustaining world was sitting right under our sink the whole time. The question then becomes, why stop at the soil? If we can transform a bucket of scraps into a biological engine, what other invisible currents are we failing to tap into? We live in a world defined by linear consumption: take, make, and dispose. But the natural world operates in circles. When you bridge the gap between your kitchen and your garden, you aren't just growing a bigger tomato. You are opting out of a broken industrial loop. You are proving that the most sophisticated technology on the planet isn't a new chemical compound, but the ancient, silent work of a billion microbes in a dark bucket. Every time you choose to ferment rather than discard, you are reclaiming a piece of self-sufficiency that was quietly traded away for the convenience of a plastic bag. The 3x faster growth is the reward. But the real prize is the realization that we have everything we need to thrive already within our reach. The path to a more resilient future doesn't require a breakthrough in a lab. It requires a return to the logic of the earth. We've spent decades trying to dominate the environment, only to find that the most profound results come from simply participating in it. This shift in perspective changes more than just the way you garden. It changes the way you see every waste product in your life. Once you see the hidden energy in a fruit peel, you start to see the hidden potential in everything around you. But this is only the first layer of a much deeper mystery regarding the intelligence of the natural world. The implications of this shift go far beyond the borders of a backyard garden. If a simple bucket of fermented waste can outperform $1 billion fertilizer industry, it forces us to ask, what else have we been overcomplicating? We've been conditioned to believe that productivity requires a heavy footprint, more fuel, more chemicals, more expense, but the microbial tea proves that the highest efficiency often comes from the smallest players. But here, where the logic takes a sharp turn. While we focus on the liquid in the bucket, we often miss the transformation happening in the person holding the watering can. When you stop seeing your kitchen scraps as trash and start seeing them as raw material, your relationship with the world changes. You stop being a passive consumer and start becoming a producer. You begin to notice the seasons, the temperature of the air, and the specific ways your soil breathes. This is the hidden cost of the modern world. We haven't just lost our connection to the land, we've lost our intuition for how things actually work. The success of this liquid isn't just about nitrogen or potassium. It's about restoring a balance that we spent the last century trying to tip in our favor. By inviting the microbes back into the system, we are essentially repairing a broken circuit. And once that circuit is closed, the energy begins to flow with a staggering intensity that no synthetic substitute can replicate. That's not the full story, though. As more people adopt these closed-loop systems, we begin to see the potential for a decentralized future. Imagine a city where organic waste never hits a landfill, but is instead converted on-site into a liquid fuel for urban forests and community gardens. The economic and environmental impact would be seismic. We are looking at a solution that solves two problems at once: waste management and food security. The truth is, we don't need a miracle. We just need to stop throwing the miracle away. Every green leaf and every thick stem is a testament to what happens when we align ourselves with the natural order instead of fighting against it. The explosion of growth you see in your garden is a physical manifestation of a deeper, universal truth that abundance is the default state of the world, provided we know how to unlock it. We are only beginning to scratch the surface of what these forgotten biological systems can do. If we follow this thread to its logical conclusion, we realize that the soil isn't just a medium for roots, it is a massive, living communications network. The fermented liquid acts as a signal booster, a high-speed data cable that reconnects the plant to a vast underground intelligence. But here, where it gets truly wild. In a standard garden, plants often grow in isolation, competing for the few nutrients they can grab from a sterile environment. But when you introduce the diversity of a kitchen ferment, you aren't just feeding individuals, you are facilitating a community. Research into mycorrhizal networks suggests that plants actually share resources and send warning signals to one another through the soil. By providing the right microbial environment, you are essentially giving them the bandwidth to talk. And this changes everything. A garden that speaks is a garden that thrives with almost zero human intervention. We've spent so much time trying to be the manager of our plants, but the fermented liquid proves that the best thing we can do is be the facilitator. When the biology is right, the plants manage themselves. They find their own water, they manufacture their own defense compounds, and they reach their maximum genetic potential without a single drop of synthetic blue liquid. Yet there is a subtle tension in this realization. If this knowledge is so powerful and so accessible, why isn't it being shouted from the rooftops? Why are our schools and agricultural programs still teaching a chemistry-first approach instead of a biology-first one? Perhaps it's because biology is unpredictable, messy, and most importantly free. You cannot control a system that thrives on its own. But that's not the full story. The real mystery isn't why the big players aren't using this, it's why we stopped. Our ancestors understood the value of every scrap, every drop of grey water, and every fermented mound of earth. We are simply remembering what we were forced to forget in the name of progress. Every time you pour that diluted, earthy liquid onto your soil, you are performing an act of quiet rebellion. You are proving that the most complex problems on earth often have the simplest, most organic solutions sitting right in our peripheral vision. The growth you see, the threefold increase in speed, the vibrant health, the resilience is just the beginning. It's a preview of what happens when we stop trying to outsmart nature and start trying to understand it. We are standing on the edge of a new era of discovery, where the most advanced tools are the ones we've had all along. When we look at a single plant thriving on this liquid, we are seeing a micro-level victory, but the macro-level implications are staggering. If we scaled this logic, we wouldn't just be fixing gardens, we would be repairing the very carbon cycle of our planet. Most people don't realize that the waste we send to landfills doesn't just disappear, it compacts, loses oxygen, and releases methane, a gas far more potent than carbon dioxide. By fermenting those scraps in a bucket instead, we are literally trapping carbon and turning it into life. But here, where the tension becomes impossible to ignore. We are currently witnessing a global decline in topsoil nutrients, a phenomenon that has left our food supply looking like vegetables, but lacking the actual mineral density of our grandparents' crops. We are eating empty food. The liquid made from your kitchen waste is a direct antidote to this nutritional desert. It carries the trace minerals zinc, boron, manganese that have been stripped from commercial fields. And this changes everything. Suddenly, the goal isn't just fast growth, it's nutrient density, a plant grown in a living, fermented environment produces fruit that is fundamentally different at a molecular level. It's more than a hobby, it's a form of health insurance. We have been taught to look to the pharmacy for our vitality, but the true source of our strength is the quality of the soil we stand on. That's not the full story, though. The most profound realization comes when you see the system as a whole. The kitchen feeds the garden feeds the kitchen, and nothing is ever truly lost. This is the definition of true wealth, a system that grows more valuable the more you use it. In a world of rising costs and fragile supply chains, there is a deep, quiet security in knowing that you can generate your own fertility from a pile of peels and a splash of rice water. It makes you wonder, what other waste streams in our lives are actually hidden gold mines? We throw away heat, we throw away water, we throw away time, all because we've been trained to see the world as a series of dead ends rather than a web of possibilities. The explosive growth of a plant is just nature's way of getting our attention. It's a bright, green signal flare, waving at us to look closer at the world we've been ignoring. We don't need to invent a new future, we just need to stop throwing the current one away. The ultimate revelation of this process isn't found in the height of the stalks or the weight of the harvest, but in the silence of the soil itself. When you look at a garden fed by this liquid, you aren't just looking at plants, you are looking at an ecosystem that has regained its sovereignty. In our quest for efficiency, we tried to turn nature into a factory, but factories are fragile. They require constant inputs, external power, and rigid control. A forest, however, is resilient because it is a closed loop, and by bringing fermentation into our homes, we are finally bringing that resilience back to our own doorsteps. But here, where the final piece of the puzzle clicks into place. We often think of sustainability as a sacrifice, doing less, having less, or moving slower. But the 3 times faster growth rate shatters that myth. Nature doesn't want to be slow, it wants to be exuberant. When we provide the right microbial conditions, we aren't forcing growth, we are simply removing the obstacles we put there in the first place. We are unlocking a biological speed that has been suppressed by decades of chemical intervention. And this changes everything. It suggests that the scarcity we are told is inevitable is actually a choice. We are told there isn't enough land, enough fertilizer, or enough food, but we are saying that while standing on top of a mountain of unused potential. The kitchen waste of a single apartment complex could, in theory, revitalize the soil of an entire city park. The power isn't in the hands of a few manufacturers, it is distributed across every kitchen counter on the planet. That's not the full story, though. The most beautiful part of this system is that it requires no specialized degree, no expensive equipment, and no permission. It is a democratization of life itself. It reminds us that we are not just consumers in a vast global machine, we are participants in a living, breathing cycle that is eager to cooperate with us if we only learn the language. The vibrant greens and deep reds of a fermented garden are more than just colors. They are a map. They point toward a future where our waste is our wealth, where our food is our medicine, and where the most powerful technology in the world is something we can brew in a 5-gallon bucket. We have spent so long looking up for the next great innovation, but the real revolution has always been waiting for us to look down.